What's up, folks? This is Pierre-André Mathieu, and I'm here with the second part in explaining in depth of the collision. Only this time I'll explain what character repulsion is, along with how it's being used in player game mode. So, going to character blueprint, I'll explain to you what this function does, the character repulsion. So, the function and purpose is applying an offset of an actor's world position, potentially as part of the repulsion logic, as it involves getting the average of array of vectors, adding an offset to an actor's location, and optionally sweeping for collisions. So this input here is the execution that triggers the logic of this function, as it is connected to the output of another function. This one here calculates the average of an array of vectors. The input array is linked to the repel vectors array, suggesting that it's calculating the average repulsion vector. This division here divides an offset to the world location of an actor, which is connected to the blueprint character itself, representing the actor being repelled, albeit an enemy. From the delta location of add actor world offset, it is connected to the division and that divides both the vector and float. Meaning that the actor will be moved by basically a divided repulsion vector. With the sweep marked as true, it indicates that the movement will perform a sweep check for collisions. With our teleport disabled, the actor will move smoothly without being teleported instantly. So this function here fits into the calculate character repulsion system, as it is the last step where the calculate repulsion is actually applied to the actors. It takes the output of repel actors and vectors and uses it to move the actors, preventing them from overlapping or facing through each other. The key points to consider is that the function applies the calculated repulsion force to actors by adding an offset to their world location, as it uses the average of the repel vectors to dictate the direction and magnitude of the movement. The sweep check ensures that every movement respects the collisions with other objects. The function is an important component in the overall system for preventing both players and enemies from facing through each other, creating dynamic collision responses. Now that I've explained to you what the character repulsion function does, I'll explain to you how it works in using the player game mode to access this function along with the calculate character repulsion. Alright, so we're on the player game mode blueprint, and the event tick here triggers the character repulsion system every frame, as it uses loops and selection to process players and enemies separately, then calls the calculate character repulsion and character repulsion functions for every character to handle the actual repulsion logic. What the system here provides is it prevents the character overlap and phasing, dynamically pushes objects away, and uses conditions to determine whether, when, and how to apply repulsion, as it makes sure a more immersive and interactive experience occurs. What we have here are essentially two for loop nodes to iterate a specific number of times, likely twice, based on the first index and last index values. They are likely to process different sets of actors or conditions. These two nodes select between options based on an input index. They are connected to arrays named players and enemies, suggesting that the selection is based on whatever loop is processing players or enemies. And there we have two for each loops. These two nodes iterate through the arrays by select nodes, as they likely process each player or enemy character uniquely. And from there, we have both calculate character repulsion and character repulsion. These two functions and that I've built throughout this project, they're linked to an array element outputs for each loop nodes, meaning that they are executed for every player and enemy character. So what this does is sets up the main logic applying in character repulsion within the game's world, as it uses event tick to ensure continuous updates. The loops and select nodes allow for processing players and enemies separately, potentially with different conditions or behaviors. Two character repulsions, both character repulsion and calculate character repulsion, are then called for each character to handle the actual repulsion logic. Key points to consider that this blueprint integrates character repulsion and calculate character repulsion into the game's main loop, ensuring that it updates constantly, as it uses the loop and selection mechanisms to process players and enemies individually, allowing for different behaviors or conditions. What this provides is a high view of how character repulsion system is triggered and applied throughout the game. To prove my point, I'm going to test it out and see how it works. As we start, this is how the event tick applies. It uses for loop. Of course, I could go over it, but I'm not gonna waste my time explaining the whole thing again, so I'm just gonna play the whole thing and see how it works. See? Exactly what I'm talking about. So yeah, that's how the whole collision system works. Now, if you enjoyed this video, please like and subscribe to my channel for future tutorials such as this. And as always, remember, what you take and learn from me is yours to do with as you see fit. So, peace out and enjoy the rest of your day.